Hi everyone. Next we study regression splines. So the idea of the regression spline is piecewise polynomial functions. So think about the region that x is less than c and x is more than c, and we fit the cubic curve for each region. So we need 8 parameters, but it's probably better than polynomial regression with 7th degree because if we use the 7th degree the polynomial, the x to the 7th power blows up when x gets larger, but here we only have the 3rd degree polynomial, so probably it behaves more reasonably. So usually we want to make this function continuous. It's not natural to have the non-continuous function. And the regression spline is a little more sophisticated method to impose the continuity as well as the same derivatives of the specific order at node points. And okay, so consider a regression spline which is piecewise cubic function and that has k nodes. So in the previous slide, we only have one node at x is equal to c, but we have the many nodes, the k nodes, and is continuous and has the same first and the second derivatives at node points. Then this is called a cubic spline, and this spline has the expression by basis function here. So if we have k nodes and cubic function, actually we only have the k plus 3 variables in addition to intercept. So it's piecewise cubic, so each piece have the 4 parameters and k nodes. That means we have k plus 1 sections. So if we think about it, 4 times parenthesis k plus 1, so we have about 4k parameters, but actually because of this condition, continuous and the same first and the second derivative at all not points, we only have k plus 3 parameters. Maybe we can see the graph first. Okay, so if we just use cubic function and piecewise cubic function, then it fits the data in each region. So x is less than 50 and x is more than 50. So this curve is optimal if we only see the left-hand side, and this curve is optimal if we only see the right-hand side. But in total, it's not reasonable because it's not continuous. If we impose continuous condition, the continuity condition, so curve becomes this. So this is much more reasonable, but it's somewhat strange that we cannot have smooth point at x is equal to 50. So cubic spline, we impose 3 conditions. That it's continuous at 50, and first derivative at 50 is the same, and second derivative at 50 is the same. So you can see that this cubic curve and this cubic curve are different curves, but it's very natural because it's connected at this point with the same derivative and the same second derivative. Okay. So yeah, and the last one is linear spline, so the piecewise straight line. So in this case, we can only impose the continuity. So cubic spline is the more smooth, so it's a better graph. Okay, so why cubic spline only needs k plus 3 parameters? So each section we have cubic curve, so it looks like we need about 4 times k parameters, but only k plus 3. And the reason is in the next slide. Okay, so the cubic function is, okay, so 3 terms, x and x squared and x cubed in addition to intercept. So, okay, so think about the most left pane, most left region of this regression. Then we have basically 1 plus 3 parameters, intercept plus these 3 parameters. And okay, so we think about one node point, and then we just across the node point, then what happens next? Then next one is also cubic curve. So we may need the 4 parameters, But remember that we have three conditions: the continuity, first derivative, and the second derivative. So basically, we lose three parameters because of that. So we only have one more parameter in the second region. So the first knot point, between first knot point and the second knot point. Okay. So for each knot point, we add four parameters, but we have three restrictions. So we only add one parameter effectively. So that's why that we only have the k plus 3 parameters. And actually, we can have more concrete expression. Okay, so on the most left-hand side, we use x squared and x cubed. And after that, just the right-hand side of the first knot point, we use another function h of xc. The xc is the knot point. And this function is x minus xc cubed plus. So if x is more than xc, then x minus xc cubed. And if less than xc, then that is 0. So this is, smooth cubic curve, and it's 0 at x is equal to c. And the first derivative and the second derivative at c is also 0. So basically, this satisfies the conditions of the cubic spline. So at knot point, we add this function. So this function is 0 derivative and the second derivatives are 0. So if we add maybe the beta times the h of xc, then still we have a smooth curve. Okay? So if we add this function for each knot point c, the entire function is smooth and the continuous at all knot points, and the first derivative and second derivative are the same for at all knot points. So in this way, we can define the regression spline. So that's why we only have the k plus 3 parameters. Okay, so in the next video we do the computer experiment of regression spline. See you then.